State Poisson's equation in electrostatics. According to Poisson's equation in electrostatics, Laplacian of electric potential is proportional to the negative charge density. Mathematically, you can write Poisson's equation, Laplacian of the electric potential del square phi is proportional to minus of the charge density rho, or del square phi equal to minus rho divided by epsilon 0. Here phi is called the electric potential, rho is the charge density, and epsilon 0 is the permittivity of free space. As I have discussed in previous video about the Laplacian. Laplacian means divergence of gradient of a scalar. Suppose you have a scalar function phi. Here the scalar function is your electric potential. Then if you find out the gradient of the scalar function, then this will be a vector. The gradient of the electric potential, this will be a vector. And if you take the divergence of this vector, del of the vector, then that will be called your divergence. Del of the gradient of the electric potential, which is a scalar quantity, is called your divergence. And divergence of gradient of a scalar, here it is the electric potential, that is called the Laplacian or del square. Del dot del, you can write del square, or you may write like capital delta. You may write like this. You may write like this. Either you may write del square like this, or that is equal to capital delta. And this is your I cap partial derivative with respect to x plus j cap partial derivative with respect to y plus k cap partial derivative with respect to z, the simple del operator. This is your del operator. And if you take the dot product of del operator with itself, that is called your Laplacian. And Laplacian of the scalar function, here the electric potential, this is your Laplacian phi, which is equal to minus of rho, that is charge density, divided by epsilon 0. And from which source you are getting this Poisson's equation? From Gauss law, from differential form of Gauss law. From differential form of Gauss law, you will derive the Poisson's equation, which I will explain in the next video. And here negative sign comes from the fact that the electric field is equal to negative of the negative gradient of potential. From that you find the negative sign. Because in Gauss law or differential form of Gauss law, you have electric field. And when you find out the electric potential in Laplacian, in Poisson's equation, then you will have a negative sign. So the next question we will discuss in the next video, that how you derive Poisson's equation from Gauss law or differential form of Gauss law. We will also derive or explain or discuss what are the physical significance of Poisson's equation. Why Poisson's equation is important in electrostatics.